Hi, I am Sébastien Rochette, and I will talk about transforming scalar analysis into documented, reproducible, and shareable workflow. This is feedback from a conference that I did a few months ago, so I will explain what we did during this hackathon together to do that. So yeah, I'm working at ThinkOR. I am a data scientist and OR expert and OR trainer, and you can follow us if you want, if you need, and everything is there. Also, what I didn't say is this presentation is already on my GitHub, so if you want to follow the PDF, you can find them on my GitHub account. So this collaboration fest was about the R software. So I'm not sure that everybody knows R software, but it's a software for doing data science. And this was in Concarneau, in France, in Brittany, this nice place. And it was with different researchers in ecology mainly. The aim of this collaboration fest was to speak about R. So we were all here because of this software. And we had 3 days together. And the first part was to do some presentations about good practices with R. So how to do packages, and how to use Git to work together, how to put all your packages and work inside a Docker container and to share it in a reproducible way. And at the end, you could also put that and learn how to work with the Galaxy user interface, which is a graphical interface to share your research work in to the planet, if you want. So we had these steps from the writing scripts in a reproducible way to sharing this packet and to share it into a UI like Docker and Galaxy. And what we learned around that, it was about how to efficiently share your work. So base principles were made for data. So we already spoke a few hours ago by Mateusz about the FAIR principles, which is findable, accessible, interpretable, and reusable. It's applied to data sets. So findable, it means that you can find where the data is, or a computer can find it. Accessible is to say, when you find the data, you know how you can access this data, and if you have to put a password on it, it should be written somewhere. Interoperable, it means that you can use the data inside different workflows. So the format of the data can be used in softwares or somewhere else. And reusable is more linked to reproducible. Is like you can use the data to combine with other data set, but also you can reproduce the data because you know how the data was built before. And if you want to add some new data to do meta-analysis, for instance, you have the clues of how to go on the field and to add some new data to this and to continue to work with this data. So these are the FAIR principles for sharing data. And I think that to share the code and to share the software that we can use the same ideas around FAIR for that. So I divided that in 5 categories, not only 4, about accessibility, so the same here, reproducibility, documentation, readability, and communication. So I will explain in the different other slides what are these 5 steps. But we tried to apply that inside our group in the hackathon to go from this coding to share the work that you do. But for researchers who only work alone in their or with 2 people in the research lab, they are only doing some coding. You have plenty of codes stored in your computer, and how do you share this plenty of codes mass to the community, and how can you do this in a way that the other can use it again? So this is a big step, and for that, I would recommend to not stay alone in front of this big step and try to go with some friends, because alone is quite difficult. So during this hackathon, we decided to work together on a common project. So one researcher was here with a project which is called Vigikiro. It's a project that look at the distribution of these bats in France. So we have some data about the distribution, the observation of bats. We have some data about environmental distribution, temperature, whatever, weather, and in France. And with this data, they do some modeling to try to model the distribution in France. So they have a workflow about this work that they wanted to share and continue to work on it. And for that, they have a lot of OR scripts. So of course, I said it was about OR. So yeah, this is about OR. So we decided to work together with the different developers who were there, to try to know how to share this kind of work, and how to apply the good practices that we presented the day before. Going back to these 5 steps about the accessibility, the work was already available on GitHub. So the researcher put all the scripts on GitHub. So you have here only a part of the OR scripts that were available at the root of the repository, and the big part is hidden inside the folder that we wanted to hide because it was too much for us. But at least we had something to work on, and everybody could clone the GitHub repository to have access to this OR scripts and to be able to work together on that project. So the first point was already okay. The main part of this work, the difficult part of this work was maybe the management of the project, which means that how to teach to people who never use this kind of tools and together, to working in collaboration, to go from this script to a usable piece of software. So first we had to dissect the work. So maybe you don't see it, but here we took a whiteboard to write all the functions, all the different parts of the project, and what this script does, and what this one. Can we link them together? Is there something that comes at first, something that comes at the end? And what do we have between these different steps? So here we identified that between the different steps, we could have some input data and output data that can be used for the next step. So the researcher had to show us all his script and all and to be able to also give an image like this about his work. And it seemed to be easy for him to do it, but at the end, when we asked him how was it for him, he said, I felt totally naked to present all my code to some strangers, some people I don't know. It was easy for me to share the code on GitHub, because you don't know if somebody will see it, or if they see it is at the other side of the planet, so you don't care. But here you had 10 people looking at you, say, okay, tell me what you did, and why do you put that in there? So it's really difficult part, but I think that the people who were there were really welcoming and friendly, which is kind of a particularity of the OR community. The OR community is made. There are a lot of work that is made in the OR community to be able to welcome anybody, whatever is your origin, whatever is your gender. Maybe you heard about the OR ladies that inspire the Pi ladies. It's some groups that help putting in front of the screen people who are not usually seen, like white men with a beard. You are not only white men doing some code, so there are other people. So the OR community is very inclusive for that, and I think that this thing that we have in mind helped us also to be friendly with this researcher and to share the work and to work together. So we separated the work into small pieces, and we opened issues on the GitHub repository to say this part of the code does that, and I would like you or somebody to work on it to make it nicer, or to work on this part. We dispatched the different issues between one or two developers, and so that anyone could work on his little part, because here the workflow was quite easy. As soon as we had some data sets that were available to do the different parts, it was quite easy to say, yeah, you can work on this small part because you have some input data and you have some output data, you know how to go from this point to the other point. So this section part, and then of course you have to manage a repository and how you collaborate inside a Git repository. How do you deal with pull requests and everything like this? But I took this part for this time. So the recipe, I mean, for this work and how to share this work is first to carefully peel back the code. So we had to identify inside the code if there were some user-specific pieces. I mean, if inside your code you say, yes, this data is on my computer at my document and settings and my name, nobody will be able to use it again. So you have to go inside it and to find all this part that could be removed, or at least be parameterized, to put it on the top of your script, saying this part, you let the user define where is the data on his own computer. And you can also cut the different big code into small pieces, so that it's easier to maintain or to see the goal of the different parts. With the R software, everything is about functions. So a function is you take something in input and you have one thing as output. So the parameterization is like the parameters of the function. So we had to put different scripts as functions, or a smaller function. And we use what we call reprex, reproducible example. This is a word that we used to use in R. Is you have one function, so you have to show a small data set that can enter it and show what is the output of that. And anyone that use this small data set and use the same function should have the same output, without having to have the big data set that you use for the entire analysis. And if you are comfortable enough, of course, you can add some unit tests on these functions, but maybe it can be later if you just start to learn how to read a function. So the first part of the recipe. The second part is document generously. We already spoke about notebooks. So in R, we have these notebooks that we call vignettes. It's done with Markdown 2. It's like the Jupyter notebook, but for R, so R Markdown. And it allows to mix some plain text documentation with some R code that will be executed during the process of building the package here, and so that it's also reproducible. If you give the same notebook and give to somebody else to compile this notebook, it should be self-contained, and anyone can reproduce the different example on it. So in this notebook, you put some also reproducible examples, but because you did some reproducible examples for the functions, you can reuse them to show how this function works and why they work this way. And in R, as soon as you build a function, you have to document the function too. So say, what does this function, what are the parameters, and what do you put in this parameter? Is it numeric, is it text, whatever? And what are the dependencies needed to use this function? So indeed, when we do that, we transform the package of the lots of scripts into a R package, because the structure of having vignettes, of having documentation for function and putting the function in a specific directory inside your big directory is called a package, and this is forced by the R community to document completely this package. So from there, we had built a small package, and of course we had to each of us continue to develop the different parts. After that, you have to add, you can add the right amount of readability. For me, OR is not a minified language, so it's not like JavaScript. You can put a lot of air inside, and when you put some air, you can breathe when you read your code. And you have to think about future you in 6 months will totally have forgot what you put inside your code. And if you can read your code like you read a book, it's easier to go back inside. There are in the OR community some packages like in the tidyverse who also give some functions that are readable, and the code can be read by anyone, even if you don't understand the OR code. You can understand. I mean, even if you never developed in OR, you can understand the code because the names of the function and the way you write it is readable by anyone, like an English text. Of course, you need to speak English. And so think about future you, and think also about the other developers who will help you, because if you want to share to the community, of course, people will give you some feedbacks on it. And the last part is communicate abundantly about your work. There are many different ways to communicate about it. You know, social media. I'm sure everybody of you have a smartphone, or almost some. You can do some blog posts about about what you did. And indeed, at the end of this hackathon, I wrote a blog post. This one is in French, but the blog post was to present what I present here today. So what we did to go from these small scripts to a shareable package, and it was also a way for me to add a little more information for the developers, because at the end of these days they are let alone with their code, and then nobody's here to help them anymore. So at least I add some clues inside this blog post to help them continue on the work alone. And you can also build a website, and something that is interesting with the OR and the OR package is this plugin, which is called package down. And with this package down, with one line of code, you can build a website from your OR package. So it uses all the different documentation parts you have put inside your package to show it as a web page. And if you combine your GitHub with the CI, with the continuous integration, this website is built each time you put a commit on Git. So this is a website that is built from the repositories that we built. So we have the first page, which is the README that you have in the GitHub repository. You have a second page, which is the references, which is the list of all functions that are available inside the package, and with the documentation of the function, how to use them, with the examples inside. And you have the articles. You have the article part, which is the part where you have the vignettes, so all the notebooks inside. So the feedback I have from this experience is that for this kind of researcher who only worked alone in the lab, the mentoring of this project was a good start for them, because they would never go alone in this project. I mean, at first, when I presented what they could do with the script and going to the package and to show the website, they were, okay, but where do I start? I will never do that alone. That's why we decided to choose one of their projects to say, okay, let's do it together and let's see how it works and how you could do it. As a researcher who presents the work, you have to accept the exposure. I mean, as I said, it's not easy to present to people you don't know your work and what is really inside your code, and to have to explain to people in front of them, yes, here I did this because I thought that this was interesting, but yes, you have another way of doing it, so let's go. So you also need a welcoming community, because you cannot say, yeah, I do not code the same way that you code, so let's break everything that you did and I will record it my way. But then the researcher will be alone in front of this script that he doesn't understand and cannot continue to maintain. So you also have to be welcoming, to accept as the helper that you can help, but help the way the other researcher understands. So This is important to be in such a kind of group. So at the end, the researcher will change his practices. This is for good because as soon as you know the entire process and you did it together, you can apply this every time you do a new code. You say, okay, I have to think when I do my code that I will do it this way because the documentation is important, and at the end I would like this website that is nice to share to everybody. So this is important. But the thing that was almost missing is the follow-up, because I only wrote this small blog post and then I just go back home, and I continue to speak with them by email, but it's not the same than being here and helping them on their own code. So maybe we can find some other way to collaborate. So transforming scatter analysis to shareable workflow is accessible to people with a little help to start, but as soon as you know how it works, you can do it alone and continue as you wish. And I would recommend for anyone, either it's for R or any other language, start with the documentation, because you have the thing in mind, you know what this function or what this part will do, so write it, not keep it in your mind. And as soon as if it's written, you can say, oh yes, my function is written, and I can share directly it because I already wrote the documentation. So it will be easier for you for your future. Thank you very much.
Two questions that are maybe linked. Can you say a few more words about reprex, which I don't know? The following question is, you don't mention in your guidelines for reproducibility test-driven documentation, basically, or development.
Yeah. So the first question about what is a reprex, it's a construction of reproducible example. Okay, there is a package in R which is called reprex, which helps you to do some reproducible example. So the reproducible example is that you have a data set and you do, I don't know, a model on it, and you have some outputs. But the data set is very big, and you need to spend 2 hours to have the outputs. If you want somebody to help you to debug this function, you will not give the big data set. So the reproducible example is like the smallest example you can prepare, so that the people can reproduce the output from the small input and can reproduce also the errors and the warnings that you have on your function, so that you can help them say, yeah, I can reproduce it in a few seconds, give me this small part of code, and then I can help you to debug this. This is a reproducible example. I didn't spoke about test-driven development. I think test-driven development is can be problematic. You have to be very careful about that, because you can think, okay, before writing my function, I write what should look like the output. This part is interesting, but if you put a lot of tests, you will write your function as you want the test to be passed, but maybe not. I'm not sure I can really explain it in a few words, but it's quite dangerous to do that. It's like you go at school and say, I would like my students to be very good at addition because they will be tested in addition. So you don't teach multiplication and you don't teach division. You spend a lot of time on additions, and in the end, yes, they have 100% of success. But what about the rest? Was it also important and you didn't think about that? So test-driven development can be creepy like this. So. Yeah.
Just one comment on the test-driven development. There's a really good book about it, and it's part of the development process that you adjust your test continuously. So it's an iterative process. You write the first version, implement the function, and go to the next level. So coming up front with a really complex test is, first of all, really hard, I would say, and not necessarily straightforward. So I a little bit disagree with what you said, and kind of agree that it's a good process to do it this way.
Yeah. So you say that the test-driven development is iterative process. when I imagine test-driven development is like you write the tests you want to have, and then you write the function to be able to success in this test. But the iterative process, of course, exists because you use the function, and at some point you will have some new data sets, and the function will not work. So the test you will say, okay, this should work. So you write the test like I would like the output of this process to work, and then you add a new test in your code so that the next time you see this function, so you correct the code, of course, and the next time you use this function, you make sure that it will work. So the test is also here to verify that when you change the versions of your code, when you modify different parts in other places of your software, that the test still pass because you verify that all the different kind of data you used continue to work. This is the iterative part. But for me, it's not what I call test-driven development, but maybe it's just a semantic thing. No.
Okay, thanks a lot.
Thank you.